All right. Well, yeah, my name's Anthony Dente. I run a structural engineering firm in Berkeley, California, but we're licensed across the country. Uh, and here are some of my team members that I'm very grateful for. We're licensed across the country primarily because people find it difficult at times to find engineers that have experience with alternative building systems. And uh, with experience comes, some of the spreadsheets are already set up. We understand what the research is, et cetera. But there's also an open engineers with open mind issue too. But I don't, it's a different story in each bag. Who's open to looking at research to get data, strength design values from and whatnot. Here we work with just about any material you could categorize under natural building or low carbon construction. Here's some straw examples, some cob examples, Adobe project down in Topanga near LA. There's here's actually some bamboo work we did in Nepal, straw bale, earthquake rebuild, some rammed earth work, some panelization work, some earthen block product work we do. And I'm also running a company that the EPA gave us we collaborated with the EPA to develop this prefabricated straw wall panel. If anybody ever wants to know more about that, or is in the business of investing in seed fundraising businesses, let me know. I'm a whole new world for me, but different subject. It might be relevant to you that I'm the vice president on the Cobb Research Institute, which pursues research and co-development for monolithic Adobe construction primarily. But and I just came out with this book with New Society Publishing on Cobb construction. I actually think that sections of it could be really relevant to all of you too, how alternative materials, particularly the code, work. But I don't think you should just buy it if you're not interested in earthen construction, unless you really like my talk and the information that I have, in which case proceed. The building codes. I shouldn't talk about building codes without talking about Martin Hammer and David Eisenberg, who are just mentors of mine and close friends that I've learned so much about manipulating the building code with, the art of doing so. And Marty was the lead architect on the Hemp Lime code in the IRC, and David Eisenberg played a huge role. And they're both wonderful. If you ever have questions, do reach out to them. And the first thing I always like to talk about in building codes, and I don't know, how have you covered this section of the building code in the class?
Not at all.
Okay. This is a
We've
strong...
talked about talking to your building department, but basically not
Yes.
any kind of index, or I'm sorry.
I did mention alternative methods and means, but it's quick and it deserves repeating. And this is historic now.
Okay, great. Definitely talk with your building officials. Don't talk to them too much, just the right amount, at just the right time, which I mean that sincerely though. We can scare building officials at times if we approach them with a little bit of information or with haphazard language, and I've seen that cause problems. The alternative section in the International Building Code, this is the IBC, which the Hemp Lime code is in the IRC, the residential code, the pre-engineered code or the prescriptive code, whereas the building code, IBC, is mostly strength design or in some cases performance design. The structural portion is strength design. I could get into the subtleties of the difference of those words if anybody cares. But section 104.11 in the IBC is a powerful section. It's not that big, and it just states that the building code is not here to prohibit any safe building system from being used, but it's up to you to prove that that system meets the intent of the building code to your building official. And it really opens up a door. It's a very powerful section, but it also gives them a lot of power too, but it requires that they respond to you in writing. And so if anybody tells you they don't do this at all, contact me, because we don't like that response. They are, as far as we understand, required to at least formally respond that they don't think what you've given them is enough. I start with this because the well, as you know, there is a hemp lime building code appendix in the IRC, in the 2024 IRC. As you also probably know from this class or elsewhere, it's probably not code in your jurisdiction at this very moment. These are other examples of natural building codes that have been developed in mostly recent times. There's some exceptions to that here. Here's codes that I've personally worked on, either been the lead engineer or contributed a lot to. And so the fact that these codes exist, I should mention that they're just throwing a wrench in our works, and they're changing the letters that are associated with all these codes. So anyone who is used to the former lettering, like AS for straw bale, it's now BJ. And the hemp lime code started as BA, but it is now BL. So hopefully you didn't memorize BA and you can just start right off with BL, unlike me, who's going to screw this up forever. I should note that like on the alternative section, the closer the analog you can get to your building, the better. So even if it's not code in your jurisdiction, it's still valuable. It's an ICC approved document that hopefully you aren't changing that much from it too. Maybe you're following every single rule. It's just not official code. And most of the time you can have a human to human conversation with someone in the building department that they can understand, right, yes, we can let you use that. If you're having a hard time, I recommend you can reach out to me or any of the professionals that the USHBA recommends to have a licensed professional try to have that conversation if you aren't licensed or don't feel like you have the authority. If I go in there, we're getting a lot of pushback. I'm starting to pull out the quotes of the ICC committee and things from the hearing, in which case, I can jump up. This is the slide. It's kind of it's a little funny formatting. Sorry about that, but we're engaging in this multi-state endeavor right now to try to get the appendices adopted. There's all kinds of places to go here. And again, I don't know the best way to have this conversation with a new group joining halfway through, but I'm just going to keep going on this general narrative of talking to codes and then getting into design details. Is that anyway, just stop me. This is a unique kind of conversation as far as presentation goes in that respect, but
that's fine. Well, if you could put it through the mind of a person who wants to build a house but maybe does not want to understand the code completely, but how they react with the building department, what sort of, when you do the engineering for these, it's comforting, right, to the building department that that an engineer has looked at this and it's going to appear in the code. So sort of what do people need to know?
I can speak to that. Great. It might be worth knowing right here that we are on this pursuit to get the appendices of the IRC are not automatically adopted in each state. Also, you might know this, you might not know this, but you're like my state, California, has the California Building Code, but I keep talking about the International Building Code. It's practically the same thing. California changes a few items and then calls it the California Building Code. Your state might do the same thing. For the most part, most of the main body of these codes are adopted, but the appendices, for the most part, need to be individually adopted. And if someone hasn't called your state and made a good argument for it, chances are, like the Cobb appendix is not adopted. The tiny homes appendix is the most adopted, but we're starting a multi-organization effort. We've got a little seed funding for it. If anybody wants to be a part of it, here's kind of the outlay of that. But first thing you want to do is get your hands on the code, the hemp lime code. And here is an example of CASBA giving away the straw bale and the light straw clay code for free, and the Cobb Research Institute doing the same. I'd imagine that the U.S. Hemp Building Association is very interested in doing the same thing. I mean, we asked for a donation, but it's a little odd that they make you pay for these things. Up codes on the internet, it's upcodes and the ICC website do allow you to view them for free, but they're not as functional on those systems. So that's why it's nice to help get the codes out in PDF form, printable version. I don't think we need to know about the sausage being made here, but here is the official vote at the IRC committee hearing for the hemp line being successfully approved 7-2. And here we were celebrating after. You maybe seen these before, but the first thing, find out if it's code in your region. Probably, maybe not, but maybe you're not submitting for another year or so. Find out if you are following all the rules. Are you one story? Are you in size design category A, B, or C? If you're breaking one of these primary limitations of the code, and you're not a design professional, you probably want to get a design professional involved if you're in a jurisdiction that is going to scrutinize your permit. Now, that you may not be in a jurisdiction like that, in which case, if you feel that you're doing a safe and appropriate design, that's up to you and your building department on for checking those boxes. But a lot of people say, why are we limited to size design category A, B, and C? It's incredibly strong. Why are we limited to one story? And it has the most amount to do with the fact that baby steps are the most likely to succeed in the code realm. And I can talk about how that applied. We were able to take advantage of a lot of aspects and systems that were already in the IRC, so that we weren't proposing a radically new lateral system, and we weren't proposing it in high seismic zones. When you do those two things, FEMA gets involved. And we work with FEMA all the time. We have a lot of respect for their engineers, and they respect us. It's not the first code proposal that they've checked over and even vouched for. They didn't stand up and vouch for this one. We didn't need them to. We had enough weight there, but they've stood up and spoke on behalf of a number of Martin and David and I's proposals before. But so I would also, you might be following all the rules. This is like to non-design professionals or design professionals. And you might say, gosh, I'm going through this code and it's like a building code. I don't work with building codes every day. You don't be ashamed if you want someone who does work with building codes every day to do your design for you anyway, just because you're able to do it with the pre-engineered international residential code. Now, maybe it's worth pausing there and just going over the residential code has sections that allow you to, how wide's your building? How tall is your building? Exactly where's your building? Well, your rafters need to be this size. They need to be spaced at this. Your wall system, your lead and bracing. Now's when we get into kind of the lead and bracing subject, that is the wind and earthquake force resisting system for hemp lime, which I played the biggest role. Now, I'm a structural engineer. I'm happy to comment on other aspects of the residential code, but the structural features are the things that I know best. I have this like natural building structural systems. This Hempcrete construction, hemp lime construction, is, from a structural standpoint, it's very fun for us to say we design Hempcrete as structural engineers, but it's the Hempcrete is the insulation that's going around our structural stuff, and we're really just manipulating conventional systems. Now, I was talking to a colleague about this today at lunch, that really for any natural building system, we call it natural building, but really there's normally a concrete foundation, there's a wood roof. It's just like a portion of the building in between that we're altering. And for some straw systems and most hemp systems, that's even more the case, because we have a stud system and we have this lead and bracing, this kind of historical bracing system. There's other natural systems that are more like concrete, and then reinforced plaster straw bale, which I want to bring up here because this is possibly an option for hemp shear resistance into the future, but when we get more technical later on, I think we can talk more about that. I'll come back and we can come back to carbon and concrete, but width of foundation, rubble trench. Anybody want to talk about rubble trench? I was the lead proponent for the advancement of the rubble trench crushed stone code sections, which are in the body of the code. But we talked earlier about now it still says Appendix BA because the copies that I have, we're still waiting for the ICC to issue the IRC, 2024 IRC. We can't get the official document yet, which I didn't realize that was so delayed. And the bracing requirements, you can kind of see here in section 103.3.2 that it kicks you to the requirements for lead-in bracing that have existed for a long time in the IRC and the documents that created the IRC. For anybody that cares, it was around the year 2000 that there were 3 different building codes across the nation generally, and they combined all of them. And so the IRC itself isn't that old, but it's this let-in bracing only goes up to seismic design category C. And that is for a few reasons. One of them is that it's not a very redundant system. Its connections at the top, here I have like here, for example, its connections at the top are connected at one point. And when you have a cyclic loading condition of an earthquake, you're going to need to perform back and forth and back and forth. Wind doesn't quite have this problem as it's a one directional load that once you engage that bolt, you're good. I mean, it's a little more complex than that, but it's not nearly as intense as a high seismic force resisting system. But we said just use the tables that exist for lead-in bracing design, but you don't have to put the sheetrock on the system. And the lead-in bracing values in the IRC are for these lead-in bracing, which lead-in bracing is called lead-in bracing because it's an old-timey kind of way of cutting out the stud and slipping in a 1-by. You all probably talk about this a lot. There are advancements to that technique that Simpson has helped drive, Simpson Strong Tie, the hardware monopoly, where they have a strapping product that's, they have interesting language in their product manual that just states that it meets the same requirements as lead-in bracing, but it doesn't tell you how strong that is, which is, I can talk more about how helpful or unhelpful I think that is. But because of that allowance, you can use either wood lead-in bracing or the strap option from Simpson. I think I had, no, I don't. Well, I guess here you can see, I don't know how much you can see this detail, but where we give all the options of strapping that's available to the contractor who's building this section. It was, there were these 2 studies that we cited, neither of them to prominent US based ASTM standards, but Bath University, and even more so this Agrabat project in France that did these in-plane shear tests. And they, on the top, you see they tested a lead-in bracing wall, and on the bottom, they tested the same wall without any lead-in bracing, but with Hempcrete in the center. And the peak load resistance was 2.5 times stronger, actually, with the Hempcrete. It was also noted that it was 10 times stiffer. And this is something that people that don't practice engineering in seismic zones just assume is an automatic plus. But stiffness attracts load, and flexibility allows for dissipation of energy. And so there are a lot of benefits to flexibility in seismic zones. But normally with stiffness comes strength as well. So you're always trying to find that balance. And this is where we need more robust in-plane reverse cyclic testing to document how much of the building's mass is going to be transmitted into force. Mass times acceleration, earthquake acceleration equals force. And so I'm getting detailed again. This is why, if you ever have to talk to your building official on why we allowed to drop the requirement for JIP being involved in the lead-in bracing requirement, it's because of the strength documentation in these 2 tests seems abundantly clear to make that small step for the low to medium seismic zones of A, B, and C. but we didn't have a strong enough argument to make this case in the higher seismic zones. And so but we did put in the language all throughout the code that we're not prohibiting use. You just need a design professional to help you, which is a little against the rules. But I hope this secret's safe with you, but we put that in because it opens doors in conversations. But really, anything that has an design professional involved in it is technically allowed to be submitted through the IBC. And you don't need to state it directly in the IRC. It's almost a little funny to state it there, but it is helpful, and we do it when they let us, if that makes sense. But if you have a design practitioner that's trying to do a custom design for lead-in bracing, there are places where you can find design values. This report is one of the best ones. It credits about 200 pounds per linear foot for lead-in bracing. Now, that's not that much. So if you are practicing on the West Coast or somewhere in a higher seismic zone, and many of you may, if you don't think you're in a high seismic zone, you may be on like questionable soil in a location that results in being size design category C. We're working with some 3D car building folks in Indiana who find themselves in size design category C a lot. Working with people in the Blue Ridge Mountains between Tennessee and North Carolina find themselves in seismic design category C quite often. And so the requirements for lead-in bracing, you might be finding them hard to work with the windows that you want on your project. So then you start exploring other options. Here is some clients have been exploring steel. Steel is normally way too expensive for residential projects, but there's this organization that believes that if they don't do any drilling in the steel and keep the steel out of the shop and do all the welding on site with an on-site inspector, that they can make that cost effective. And I don't know if that's turning out to be true for them. But this is a way where you can use steel moment frames to keep your structural engineer essentially out of your business on your wall system. And so that you can come in and do as you please between it, and all the global lateral load systems are taken care of up there. And here's an example. This one's up in the border of Portland and border Oregon and Washington, where a client just wanted to try to isolate shear walls in the corners and then be free everywhere else. Those diamond symbols with the 4 in them represent that. So I want to just open it up to questions.